go. All right. Would anyone like a minute or two more before we get started? Nice, nice, nice. We'll get started about now. So, first of all, do any of you guys have any questions in general about the research, or want a quick recap on what we're doing or where we're at? Just anything in general. No such thing as a stupid question. If you do, just unmute and say it. All right. So we'll get started. So I guess where we left off last time was that we downloaded Panoply, which is NASA's, which is a tool NASA developed for using or for viewing Cdf files and visualizing them. And by the way, if any of you have a question at any point, just unmute and interrupt me. If you haven't downloaded Panoply yet, there are instructions in the Hurricane Research Doc, I think version 2, just like links and whatever you might need. That's in the Google Drive. It's in the Discord as well. And then, so with that, having that, we were looking for actual files from the GOES satellites. So we tried a couple of different ways. We used the McFetch tool, and ended up finding a way to get those files using a website called NOAA class. So I'll walk you guys through that right now. All right. So you guys go on the Hurricane Data Research Doc 2. It's in this general Google Drive folder. I think it's in the Discord as well, or it should be shared with all of you. On the Hurricane Research Doc V2. McFetch ended up being a bit of a flop, so we'll cross this out for now, although we might want to come back here. It's not what I want. So 2.1, so NOAA class is basically this website. It was on the GOES R PowerPoint that we had before, although we don't really need that now. It's basically a way of pulling data from NOAA. And if you're not aware, NOAA is the organization that actually runs these satellites. This is the main website that they give, or that links from the PowerPoint. If you just go in here and you look at GOES, you'll get a lot of GOES R satellites, but if you remember, we're not using GOES R because that's 2017 and onwards, I believe. It might be 2016, but we're looking for data from 2000 to 2015. So we have two things here: the GOES satellite data, block 11, GOES satellite imager, and the sounder. And then this is very old GOES stuff. So these three things are the main things that pertain to us. Also on the doc, I kind of created a summary here, and I talked to our mentor about it. Block 11 is pretty much just metadata. We don't need this. The imager gives us pretty much, as the GOES satellite goes around Earth, it's just pictures of the ground, just of the surface, or not of the ground, just the surface, whatever it sees. Whereas the sounder is a slightly more complicated tool, and it'll give you like these vertical slices of here, which one you could disaggregate. Okay, this is like the thickness of the clouds at the top. Then we have the mid-level water vapor. Then we have some stuff below. Then we have the ground. And it lets you separate all these out. All of these you could pull from the website. And here's some stuff where I was just looking online trying to figure out what these are. I found out about this just like a week ago as well. So don't worry if it's a lot at first, but you'll be able to grab it pretty fast. Basically, I went on this website and I tried to do a quick data order. And this is something that I'm gonna ask all of you guys to walk through today as well, the process of ordering this data, making an account on this website as well. And we got some stuff. So basically, yeah, we'll start by just playing around. So I'll send this link in chat. And do all of you guys, this is a quick question, do all of you guys have the ability to download things on your computer? I think Ananya, I don't know if you could do that on a Chromebook.
I'm not sure. I can try.
All right, go for it. Yeah, might as well. You can make an account as well. Cool. So if everyone can open up that website I sent in chat and pretty much just follow along. And if you want me to slow down or give you a second at any point, just feel free to unmute. So process would pretty much just be going on here. We're going to be starting with the sounder. The specific data for each of these, they're all similar, so we could really use any one we want. There are some minute differences. Honestly, I'm not sure if there's going to be which specific one we use is going to be important for our research, but we find that out through trial and error. So you pretty much just select the sounder, go satellite data sounder, sort alphabetically. Go there. And then you have a bunch of inputs here. So you can start with just the spatial one. This will tell us like it goes to satellite. So which area in particular do we want? I put some pretty specific numbers here on the dock if you want. You could copy paste that in, or you could just roughly select a region around here in the North Atlantic. You could zoom in with the scroll wheel, but that also makes you move to the side. Or you could side click. This website is not very fun to use. Yeah, if you want to roughly select a region like that, or again, like I said, you could just copy this and paste it on here. So this is something I want you all to do now, just to get familiar with the process of this. Yeah, so a region about that big, maybe starting from just a little bit down here, all the way down to just off the top of South America. And so the particular data that we're ordering here, like I said before, we're starting with Hurricane Sandy. So the dates for Hurricane Sandy, where it was just going from 2012 October 22nd to 2012 November 2nd. So you can just paste those into these start and end date things. 1102, leave the times there. We'll just go from the start to the end of there. And then once you have that down, we want to select the North Atlantic region because that's the area that we'll be studying for our research. Satellite, of course, we're going to be going with GOES 13. We could use any one of these really. Actually, let me check the days because I already did an order of GOES 13 and I have that ready for all of us. We could try a different satellite. Let me give you guys some new data to do. So GOES 13. Yeah. Two 2006 to 2018. Yeah, we could actually, oh wait, no, this goes. We could try GOES 14. You know, let's go with GOES 14 this time because we already did 13. So let's select GOES 14 right here. Or real quick, does anyone want me to slow down or explain anything from before? Looks like we're all good. So once we select GOES 14, we want to click on search. Wow, amazing. Never mind, go back. We're going to be using GOES 13 after all. Let's go with GOES 13. Yeah, we should get about 47 data products right here. And this is what I did before. So from here, I believe, I'm not sure what it says on your pages. Oh, I'm not logged in either, so it should be something similar to this. From here, what you might want to do is that, so this website lets you, I'm sorry, I should explain from the beginning. So these are pretty much all going to be individual .cdf files that we can grab. Over here, we'll see the time and the end time of this specific picture that it's taking, the satellite, and then the coverage region. You could click on each one of these specifically, and this will give you a bit more information. Sometimes it'll give you pictures, but there's some more information. Most of these I don't understand either, but just in case you need it, it's here. You go back to summary. So because we got 47 hits and our max number is 11, we could just select 1 to 47 data sets right here and add all of them to our cart. Then from here, we could just go to our cart. And then I think at this point, this is the size of it. So once you guys do start ordering stuff on your own, be careful with the size of it, because you could very easily get into the realm of like 8 gigabytes of stuff, which is, we'll have storage for that at some point. We'll get either external hard drives or Google Drive or Dropbox extended storage. But just make sure it should be about the size. If you're only getting 1 day's worth of data, it shouldn't be like 10 gigabytes. use that as a little check beforehand. So right here, of course, you want the net CDF data format. And so once you select it for one, it'll apply to all of them, 16 bits per pixel. And let's just order all of the bands right here. So leave it selected. If you choose one specifically, you can drag and drop or just press Control A, and this will select all of the bands. So what we should have applied to all of it is net CDF, 16 bits per pixel, and all of these 19 bands. And then from here, we want to register for an account. And then you just want to fill out some information here and register. It might bring you all the way back when you're done. I already have an account, so it's going to finesse my way into it. Will it reset everything? Yeah. So whenever you as soon as you finish what is it called? Once you finish registering and you have an account, you might have to go on your email to do it. Just go on Zoom and give one of those green check marks to let me know you're done. It should show up on my thing. So yeah, get to it.
After we select net CDF in the shopping cart, where do I go from there? Sorry.
So, oh yeah, you go to cart, you select net CDF, 60 bits per pixel, all of them. You want to go to, or did you register, did you log into the thing?
No.
So yeah, if it says register here, then you want to click on register and just make an account on NOAA.
Okay, got it.
And then once you do that up here, there should be a little login, and you might have to go through the whole process again.
Where do you get your username from? Because I signed up and nothing happened.
It's either emailed, or if your email was like, let's say johndoe@gmail.com, I think your username would just be John Doe, whatever comes before the app. That's what it is for me.
It didn't work for me for some reason.
Is it saying that it's that you have like the wrong username and password?
It didn't say anything when I tried to log in. Just
What do you mean?
refresh the page.
If you look up here, does it say login register, or does it say log out?
It says login and register.
No.
I'm gonna try registering again. Alright, I just registered again.
Yeah,
Login.
try. So go to login and then just username, password, and then login. That should get you to where you're going.
Should I press place order once I did it?
Uh-oh. Yeah, if you should have 47 in your cart, you should be will be notified at, and then your email. Net CDF, 16 bits per pixel, all bands, and then yeah, just place order.
Yeah, it's really weird. It says incorrect login.
Yeah, that happened with me before too. You might just have to
I'm gonna request a username.
yeah, it's somewhere here. Yeah, click for a username request and then just enter your email and it should send the correct thing. It might be the same thing that you originally registered with.
It says that I never registered. What?
Just try registering again, I guess.
I registered twice. That's weird.
Does it have like a confirmation email? Like you have to go to your email and confirm?
I checked my email, it didn't send anything. So.
That's weird. We'll spend like another 2 or 3 minutes on this. If not, basically, as you guys are doing this, because these are like really high quantities of data, it's going to take like a while for it to send. Usually just like it takes like an hour or two, but for really big orders, it might take like a couple of hours. They said like the max might be 48 hours to 5 days. And so waiting for that, I already made a request earlier. And I'll show you guys what the original email is, and then I'll show you guys the process of actually from that email how to download. Because it's not just like there is no like single data RS website that you could just go on and say this date to this date, please, and it gives you everything all packaged nicely. These data sets are kind of old. It works, but you kind of just have to learn how to use it. And the learning curve initially is going to be pretty steep. So I'm just walking you guys through this process. We can do some cool science.
Oh, there you go. Now I'm in.
Nice. You might have to go through that process of finding a data product or entering all those parameters again. I'll go through that real quick.
Oh yeah, just give me a sec.
If you're still in the process of like just registering and all that stuff or putting in the inputs and stuff, could you unmute and just let me know real quick or say your name?
I'm still downloading it. I registered.
Okay.
It was just having issues with my password for some reason, but
Or Ananya and Chris? Okay. What am I?
Quick question. I missed last week's meeting. You said we downloaded something. What was that again?
Oh, if you go on Hurricane Data Research Doc 2, it's section 1, net CDF file viewer. It's this thing called Panoply.
Oh,
You also have to download Java, which is as a link for it right here.
all right. Sounds good. Thanks.
No, I ordered it. It went through.
Nice. We'll give like a couple minutes for us to go through it then. Ananya, were you having troubles before? Or did you get that solved?
I just placed my order.
Oh, nice. Is anyone else done? Has everyone placed their order so far, or is anyone else working on it? All right. I assume you're all good. So once you place that order, you should get, I think, you get an email for registering, get an email saying verified, this is the order you made, and these are like specific data products you got. And then a couple of hours later, you'll get a verification. I'm gonna stop sharing real quick. I did this earlier and I got us all, so we wouldn't have to wait, so we could do this all now. I'll show you an example of the verification email. I just have to tell which order it is, 1 sec, because I made 2 orders. This might take a second. Okay, let us use one of these. Yeah, I think this is the one. So so this is kind of I'm going to be a little careful. I'm going to err on the side of caution and not give the key that I got out to everyone. That just in case if we all log into the thing at the same time, it might give us an error if we're all using the same key. So I'll just share my screen and show the process of this. Later on, I'll ask you guys to go out and pull your own data products or the one that you just ordered. You could you could replicate the kind of instructions with that one, and you can download all that. So I'll share my screen real quick, and I'll show this process. So basically, this is the email I got, class order processing complete. This came a couple of hours after I placed in my order. I think for this one, it was 2 or 3 hours afterwards. And you get this long thing. If you open any one of these, you're not going to get anything. It's going to be a site. These aren't links. It's just how Gmail formats it. There's this website down here. You can pick up your data by this and you could manually download each and every one individually. But we're not scrubs to go through and click a bunch of links to download stuff. We are expert programmers. So we're going to download all of this in a really, really cool way. So basically what you do is that you're going to press, and you guys can't do this right now, so just watch along and watch back on the recording when you're actually doing this on your own. You're going to press Windows R, type in CMD, which opens the command prompt. And I'm not sure exactly what the equivalent for this on the Mac is. If you want to look up the Mac equivalent, just either reach out to me or look up how to make an FTP copy. But this is general procedure that we're going through. Gonna Windows R CMD, open this up. And they're pretty much going to copy the commands here. It gives a command and they'll give a dash or a hyphen and what that actually means. So we will split this half and half. The first one, it's kind of cool when you think about what you're kind of, I'll let it speak for itself. So you just do this, copy, paste, and enter. You see here, accessing US government computers. Ooh, very cool. We're pinch promoting into the actual computers by the US government. We're downloading stuff directly. We enter a username, which for our case is just anonymous. Our password is user@internet. It's always like this. Oh, you have to enter this. So there's a thing with these things, with this type of login by the command prompt. If you type something, it's actually going to show up. You just have to be very, very careful. So I'm typing in things right now, typing user@internet, but nothing shows up here. But just when you press enter, it should. Oop. Yeah, so I messed up before. I have to log in. That's unfortunate. We'll just go to the command for. We'll try that previously. FTP. I think you say by. Yeah, we'll try this again. My bad. If you say by, that comes out of it. So we're back here. It's just the users and then your name. Type this in. This logs you in. I'll start typing in manually. Anonymous should get you in here. Any password from user@internet. Nice. Oh, I did get in before. Oh well. Once you're in here in the FTP, now you're actually in here. You want to type in binary. Specify the data type. CD. And then this number, this kind of goes to the correct folder in the computer that we're remoting into. For this, and then we pretty much just want to copy all of these and paste it in. And this will take a bit. Make sure to stop before this very last by quit thing. And then it's pretty much just going to run through each one of these individually and download it all onto your computer. While this is running, because this might take a little bit of time. Yeah, it's going to take a while. Yeah, so all this is kind of running in the background. I'll show you guys the process of, I already downloaded some of this data before, not this exact data product. So this, what we're getting is GOES 13, all of the bands. And because this is the sounder, we are getting every single kind of layer of the atmosphere. Previously, I downloaded GOES 13, just band 13, which I'm not sure exactly which kind of wavelength of, or which slice of the atmosphere that corresponds to. That's something I'll be talking to a representative from NOAA about sometime later. But yeah, from that data, if we go on Panoply, and I uploaded my first order, the band 13, onto the Google Drive, so you could download those .cdf files and go along with it. In fact, I'll do that. So we're all looking at the same thing. If you go to the thing, order 1 Hurricane Sandy, and then just open the very, so you don't want to get the .meta ones, you want to get the .nc ones. We'll get this one. I think this is for, or how about this one? You organize by name going down. So if you click on name, get the downwards arrow. We'll just download the second one, which is this one right here. We download that. Open up Panoply, which we got last time. It'll originally ask you for a file like this. I have it directed to the files on my computer, but you could just go on Documents, nope, this PC, this one, Users, your name. Oh, these are the files that we're downloading right now. Downloads. And then you should see the .cdf ones, I think. So this is 20307. Yeah, this one. Should be able to open this and should import into Panoply. Alternatively, because that's kind of complicated, you could just press like Windows E, go straight into your thing and then drag and drop the file that you just downloaded into Panoply, and that'll give you the same thing. So whenever we're all at this point, just let me know. Just unmute and say, yep, I got the file on here.
It worked for me.
It's okay if I just follow along, right?
Oh, because you don't have Panoply. Yeah, of course.
Yeah, okay.
How's everyone else doing with this?
Wait, does it matter which file we drag?
You could get anyone really. It doesn't matter. Just any .nc file. You just want to drag it into Panoply.
Right.
I can't find Panoply on my computer.
Did you install it last week?
Yeah.
Try pressing Windows and just type in PANOPLY. You should get a .exe. Is that there on your computer?
If I have a Mac, is it the same thing?
On Mac, I don't know how to search for programs on a Mac.
Just do command space.
Okay. And then
Sure.
command space, and then what do I do?
Look
Just
for-
type in Panoply.
So Andric, Debbie, Elena, are you guys at this point? How are you guys doing?
Yeah.
Nice.
Yeah.
Debbie? Oh, she might have had to go. That's fine. We're recording later. All right. So once we're at this point, we're going to see all the files that are contained within this individual, I guess, snapshot. So I guess just backing up, this .NET-CDF file is a snapshot of the Earth at a certain time using one of the tools on the GOES-R satellite. We could see a bunch of stuff, I guess, over here. Let me center it so it's actually. Oh, sorry, Zoom's not the best. You'll see all the different variables here. Usually very first you'll see the type. So this is just a character. It's just saying that this is the audit trail. Actually, that's a string. That's strange. Integers, which is saying the number. Oh, sorry, never mind. Yeah. Bands is an integer, and this is just the 13 because we're using band 13. This is the date that we're using, so 2012, date 307. The time, probably in UTC. Yeah, hours, minutes. And you'll get some details here. The data, some more specifics. And the ones that we're looking for are the local file, the one that says GO2D here, the raw satellite counts. Or it'll say data, this is what we're looking for. If you double click on this, click on the geo-referenced longitude, latitude, color contour plot, and press create. Should work some magic. And here we go. Very cool. Press control and click, you should be able to zoom in. And here we have data from a government satellite going around the Earth. Very, very cool. If you have any questions getting to this point, let me know. I'm going to give everyone a second to follow along and get here.
This is unrelated, but there's like a meeting timer on Zoom for some reason.
Yeah, it goes up until 40 minutes, I think. If that ends, just because I think it. Oh yeah, it says 6 minutes left. It starts when everyone joins. We'll try and wrap this up soon. If it ends, then just I'll send you guys another one. But we should be able to wrap this up.
All right.
Wait, so I have a quick question about this data.
Yep.
So isn't this just singular points in time of the data set that we requested?
You can't really get singular points in time because it takes the satellite a little bit of
Right.
time to like scan over it. So you'll see the data range on the original NOAA class order. So
Right.
this is a very short period of time, basically. Yeah.
So my question is, so how would we be able to like actually see trends like easier than looking at every single graph?
I'll go over that shortly.
Okay.
And that's what I'll leave you guys with. But yeah, no, good question. You're already thinking. Good job. This is raw satellite counts, in case you're not aware. There's like intensity where red will pretty much indicate a lot of clouds, blue will indicate no clouds or pretty much ocean. So here we see a lot of clouds. If you want to unclick, you could play around with these settings. I encourage you to play around with this. It doesn't have that much stuff. This is kind of not a very good program. It doesn't have some filtering things that I really wanted, and I banged my head for a while. trying to fix this, or trying to find the features I wanted. But the one good thing is if you press if you unclick this interpolate thing, you can see the individual pixels, which isn't useful until you zoom in a lot. And then if you click on array, you can see all the individual values. And these are the things that we're actually after. If you press Alt and click on an individual thing, it'll give you like the actual cell array thing, something you play around with more. And yeah, this is basically just the data we've been after. Finally got it. Right, so does yeah. All right, that's something. Does anyone else need help or guidance or any questions getting to this point?
What do those numbers like? What
The
sort of
setup?
data are they giving?
Yeah, so the unit for this is there's no real unit because it's basically just shooting light down and seeing how much it gets back. This is all just relative intensity to itself, saying like, did we get a reflection from this cloud or not? There might be a unit, but I'm not actually sure. And by the way, if you go on other files, this might be very, very blue. I actually got lucky with the file we got that this is a good distribution of colors. And that's because actually you'll get like cosmic rays from other galaxies that'll come in and flip bits on the original data. That'll cause some regions where everything else is just like 100 to 1,000. This one region is like 1,000,000 because that single bit of data got corrupted. But basically, yeah, we'll get to this point in the data, and I will speed up a little bit because our Zoom time is running out, which is unfortunate. Basically, what we're gonna I might let this one run out, and then send you all another invitation. Can I live plan a Zoom meeting in the middle of this one? Because I'd rather you guys have the link now than schedule a new one at 6:45. Cool. All right, here's the next Zoom meeting that we're going to hop to because Zoom, we used to have longer meeting times on our accounts, but we took that away from us. So here's another Zoom link. I just put in the chat. Feel free to leave this one and transfer over to that Zoom meeting. You can do that right now. Nice. Start recording again. Share my screen. So where we left off was that we had this graph on Panoply, just basically the region that we're looking for. Another way you could look at this data, so we did the georeference longitude latitude color contour plot. I encourage you to play around with these. Another way you could do is a color contour plot using X for the X-axis and Y on the Y-axis. You can create this. And if you just compare this to the one before, you'll notice that it is flipped, which is kind of weird. Still not sure why that is. If you put them side by side, the little red bit is on here, but the red is at the top here. But this is just another way of looking at the same amount of data. The array is still the exact same. It's just a matter of how you map it onto something. This is just a square. This is kind of stretched to fit onto the Earth, but they both represent about the same.
I think it's flipped because on the first map, as you go down, the latitude increases, but on this one, if you go up, it increases.
Yeah, that probably makes sense. Yeah, that's actually a good explanation. Yeah, good job. So yeah, other stuff you go here, you play with the settings again. And so yeah, basically what we'll be doing, what our next task in this research is, and this is something that I'm going to leave to you guys a lot. A lot of this was kind of guiding through it because this is where we've been kind of got. It's been a bit confusing to get to this point. You know, it's good. It's kind of a learning experience to learn how to look for these things, how to play around with things, trial and error. It's a good thing to go through. But now we have kind of more straight line forward, but it is a little difficult. So basically what we're going to do is that we're going to take this. So this is a vision. Panoply is a way to take the net CDF file and the data and visualize it on a map. So Panoply is making this, but the actual data itself that we're getting from the satellite, the net CDF, is all stored in this array. These individual counts tell you how, I guess, bright each of these pixels are in relation to each other, where the pixels with a really high value would be very red and pixels with a very low value would be very blue. The blue ones being ocean, the red ones being clouds. So yeah, essentially what we're going to be doing is that we're going to be taking a lot of these files and we're going to look through these arrays And let me see. We're going to be making a histogram. And if you recall, you can have histograms like how we, like when you first introduce histograms, you're introducing the context of grades. You can have all these bars. This is going to represent, let's say, the distribution of grades on a test. You'll have your A, your B, your C, your D, and your F. And this will be the number of people who got it, or who got each of these grades. And so basically, we're going to create a histogram like this for our data. But instead of having our grades, the thing that we're going to be graphing down here on the x-axis is the number of satellite counts. So over here, all the way on the left side, we're going to have the it's not blue at all. We're going to have the very blue satellite counts. So this is representing just ocean. So how many pixels on that net.cdf file, or how many pixels in that picture were blue? So how many were ocean? And then as we move to the left, we'll get slightly more red. So this is like light clouds. And then all the way on the right where we see that this is just like a cloud. We know for sure this is a cloud. It's a very thick cloud that we can't see the ground at all through. And again, on some of these files, I should show you guys what I'm talking about when I say that some of these are not the best. If I go through my, and I'm also directory. Let's research Albedo, first order. Just order any one of these, open any one of these and look at the data. Yeah, so this is what I mean. Most of them are going to look like this, and I'll explain why real quick. Most of them are blue with these really hot. Oh, it's kind of cool. You kind of see the swirl of the hurricane moving across. This is Hurricane Sandy. You'll see these little blue spots, and if you turn off the interpolation, you'll notice that's just singular pixels. There's a really cool Veritasium video on this on YouTube if you want to come check it out. But essentially, kind of radiation from, I think it's called cosmic radiation. I might be butchering this completely, but basically, radiation from other galaxies will come and hit the inside of the satellite, and it'll kind of cause a bit of corruption in the data. So that'll cause these values just randomly. Sometimes it'll be one, sometimes it'll be a bunch like right here, but these will be stupidly high values that don't make any sense. So this area of blue has a value of 1,458. It's all the way on the bottom right. So it's 1,458. This is 64,000. So there's no reason why this place should be like an order of magnitude more, why the clouds here should be an order of magnitude more thick than directly above or below. There's just a corruption in the data. We don't need to worry about this. But basically what we're going to do is that we're going to look, I actually messed up. This is water. This is not hurricane. Sorry, the hurricane is the white part. I just realized, oops. So the hurricane is the white part, the water is the blue part. Because if you look down here, satellite counts, blue means water. The more counts, the more clouds you have. I think, unless I'm getting it completely backwards. We'll figure that out later. Yes, that's fine. So go back to the paint file. We're pretty much going to make a plot like this. And although the colors might vary from thing to thing, what we're actually going to have here, the colors are just a way for us to visualize it on Panoply, but these are actually going to be on numbers. So 0 is definitely going to be all the way at the bottom. We're going to know for sure that this is water. And then we're going to have some max value here, let's say 2,000, where you know that anything at this point is for sure a cloud. And then we're going to create our histogram, and each one of these are going to be arranged. This might be 0 to 100. You know that for sure this is water, everything for here. And we're basically going to want to look at this net.cdf file and see what is the relative like frequency, how many pixels are between this range, how many pixels are between this range. I'm just going to create a histogram like this. And then we're going to do this thing called thresholding, where we're going to say, okay, we have to set a mark where anything below this number, we're going to consider as water, and anything above this number, we're going to consider as a cloud. So let's just say we arbitrarily decided it's at this number, and we set the threshold to be, I don't know, like 800. I'm just throwing a number out there. This is our threshold. What we're then going to do is that we're going to take this histogram and we're going to see, okay, how many pixels are above this threshold? So how many pixels are we saying definitively represent clouds? Let's say this ends up being, I'm completely making up numbers. Let's say we got 10,000 pixels we know for sure clouds. And then the things below this threshold, let's say we say 2,000 pixels, we know for sure are water. Actually, I don't feel like doing that today. So that 8,000 pixels are clouds, and 2,000 pixels are water. So using these two numbers, and this is all going to be done through code. This is something I'm going to give to you guys to kind of work through, kind of export the data, use Python or Java, whatever you want to get these numbers. We're going to find the ratio of, let's say, cloud pixels to total pixels. So that would be 80%, 8,000 over 8,000 plus 200 plus 2,000, 8,000 over 10,000, 80%. And that's going to be our quantification for this picture. We can know definitively that, let's say that's data that comes from this picture, that 80% of the Northern Atlantic at this time in this picture was covered by clouds. And that's going to be the number that we're after. And we've, by doing this, by creating a script that automates this, we've effectively found a way to quantify the cloud cover over a region at a certain time, which is pretty cool. And then, so that's the project that we'll be working on for the next month or two. I think you guys are pretty busy with college application stuff coming up. I know you seniors, other people are just focusing on midterms. My winter break is starting soon. I'm very, very busy for the next 1 or 2 weeks. So basically what I'm trying to say is that over the next 1 or 2 months, this is something that we'll be working on continually. Hopefully in January, when you guys are more free, we could start investing a lot of time into this. I'll be working on this in the background too. But yeah, hopefully in a month or two, we'll have some kind of Python script that does this for us, that'll get these numbers. That'll take that'll take a net CDF file and quantify the number or the percent of cloud cover. And then past that, if you're curious, this is more up in the air, or this isn't as well defined so far, but past that, what we're gonna do is that pretty much right now we'll use that, I guess, that script just on this data. All we have right now is data from Hurricane Sandy, but you guys learned earlier how to order more and more data. So we're gonna order a bunch of different data products. We're gonna get a very, I guess, big array, or a big, what's the word I'm looking for? Pretty much what we're trying to find is that from, if we want to find some year, month, day, and time, we want to be able to immediately from that pull the percent cloud cover at that point in time. And then from that, we could start, that's where we introduce the Albedo data, or the solar reflectance data. And we're going to try and find correlations between, okay, there's a lot of cloud cover that day. Do we find that there's an increase in albedo that day? And we're going to start doing some more graphing stuff, some more data analysis stuff, but that's way off in the future. Right now, just to recap what we did during this meeting and wind everything down, we learned how to order these net CDF files from the NOAA website. We learned how to kind of just look at them in Panoply just to get an idea of what does this net CDF data actually mean? How can you visualize it? Moving forward, what we're going to try and do is that we're going to try and take this actual net CDF data, this array, we're going to try and export it to Python, and then use Python to kind of run through this, kind of create a histogram from it, and then eventually choose a threshold from which we can say anything brighter than this is a cloud, anything darker than this is water. We're going to try and find a ratio between those and use that to quantify the cloud cover. And so, what a great job here. That is about all the information I'll be lecturing you guys or throwing on you guys for this session. Does anyone have any questions, concerns? Again, there's no such thing as a stupid question. I know I'm throwing a lot at you guys right now. If you want to directly message me afterwards too, that's fine. But yeah, any questions, concerns, comments?
I'm assuming that the ratio you said earlier, like about the clouds to water, doesn't account for like the thickness of the clouds, right?
In order to account for the thickness of the clouds, we probably need to talk about oops, where is it? I'm not even sharing my screen. Never mind. Yeah, so we have to look at the colors. Right now, we're starting out very simple. We're just looking for a ratio of clouds to water. Yeah. Yeah, we're looking at just either cloud or water assignment. Sorry. Yeah, anything else? All right. And by the way, Andric, it is good that you're thinking about that certain clouds, it doesn't make sense to just delineate things or categorize things into clouds and water, because some clouds are thicker than others. You have different types of clouds, different reflectance. We might, if I doubt we'll have time. We might have time. There's another NASA satellite. I think it's called, I completely forgot the name. I'm not even going to BS. It's on the proposal somewhere though. And that does take into account the actual specifics of the water crystals in each cloud. We might get to that later. But right now we want to start very, very simple already, even though it's simple, it's still pretty complicated. But yeah, it's good that you're thinking about that stuff. Keep that stuff in mind. We'll address that stuff later if we have time. So yeah. Any other, yeah.
So with Python, will it open the NetCDF data in the same format, or will it be drastically different?
What do you mean the same format?
So will I be able to see like array and like the way it opened up on your screen, or will it like look different?
You know, good question. I'm not 100% sure of that myself, but if I were to give a guess from working on different things before, the way Panoply is showing this right now is that this is just the original file. Once you open that, you're going to have all these other things. How I imagine that being structured is that you're going to have your individual file. And then within that, you're going to want to access some variable. So in this case, we want to access the data variable. So if this is just being stored in a dictionary format, we'd have to specify data. And then this, as in variable form, will give us hopefully access to the 2x2 array, which we saw here. And I think this is what you meant by format. Hopefully, it will just give us just a simple 2x2 array where, let's say, you access. This is not indices. This is indices. If you access, let's say, 618. Oh, my eyes are terrible. If you say 618, so we go back to the paint, and then we were to access x index 6, y axis 18. Hopefully, this should spit out the specific number 8,993. But this depends on how NetCDF works with Python. This could be completely wrong, but yeah, this is how I imagine it'll work. This is something we'll learn as we go on.
All right, thank you.
No problem. Anything else? All right, sounds good. And one more thing I'll show you guys. Sorry. I think I finished. Oh, this isn't recording. When you actually download the stuff from NOAA class, I know you guys haven't ordered stuff, but your verification could come soon. I think it is just a good exercise to go through that process of what I did before of entering everything into the terminal. You see the stuff happening on your command prompt. Oh my God, it's still going. Wow, wonderful. Maybe don't order a piece of data that big. If you want to place another order just for 13, or just band 13, what I had, or band 12 if I'm ground, or band 9. If you do it, I'd recommend doing band 9 because that's one that we're interested in right now. As this is downloading, it won't download in your downloads folder. You're gonna want to go to this PC. No, not this PC. You want to go into your OS drive, whatever OS you're in, your users, your name, and then for some reason it's all going to be in this file. You just want to copy paste it over to whatever thing you have. I made like a little research folder and I sorted it all into a single order. Yeah, the meta files, honestly, these are just text files. You could probably delete them. I'd keep them, but they don't give us that much information. Pretty sure they're only ever like 1 or 2 lines of text. Yeah, this is useless. No one cares about this. Although they might be useful for a panel, I'm not sure. But yeah, that's the only thing I want to show you. If you actually place an order, they're all going to be found in. Yeah, this is gonna run for another. It's gonna run for a while, unfortunately. But yeah, that's all the information I have to dump on you guys. I guess tasks moving forward would be I'll start assigning these more manually. And if you have time, if you ever have time, feel free to message me. And there's always stuff there for you to work on, all types of stuff. There's not that much, there's a bit of math stuff maybe, but a whole lot of programming stuff if you want some self projects. And you will be credited in the final paper or final presentation. Like they'll say like this student or this scholar wrote this amount of code, and that might obviously be recognized for your efforts. I'm not forcing it onto anyone, but at the same time, if you do voluntarily choose to do work, then that's obviously going to be recognized. For your exceptional efforts.
I have a quick question.
Yeah.
If you have a second. For the data that you gave to us for the GOES 13, what is the time format? Because I can't seem to.
The time format.
Yeah.
In the
way
Google
that they're
Drive.
named. Yeah, the way that they're named is very interesting. I'm trying to put them in order, but.
Yeah. Thankfully, Panoply kind of lets you parse this data. So if you look at the CR date and CR time variables, the actual variable value is going to be down here, but the description of what that, I guess like some documentation for that. So CR date is going to be CC year date. Where is it? Probably Google this and find out what it is.
Because I'm just trying to concentrate all the net CDF data into one single array so I can view it. But
All right. And then the time is in, are you aware what UTC is?
yeah.
Or, yeah, universal time. I guess it's an hour, minute, second. Oh, but you're talking about the actual file names, probably.
Yeah,
right?
I'm just trying to read what are the file names and I can't
My
seem
bad.
to.
So I guess it's year. This looks like day of the year. So this is a 305 out of 365 days in the year. And then this might be time. I'm not sure how this time is. This might.
Is it like 14 hour, 20 minute, 15 second? I don't know.
So this file itself is 2012 298 142016. This cell is 14 hours 20 minutes. Yeah, I guess it is just that. Panoply has a little
it just is in order. Okay.
Yeah. Can you see what I'm like pointing at on Panoply?
Yeah.
Yeah.
Okay. Wait, so I'm just curious what the 298 is. It just
298. I think that's the day 298
298th day. Oh.
Yeah, of the year.
Okay, that's interesting. Okay, thank you.
Yeah, no problem. Okay. Any other questions? All right. So just say one more time, our task moving forward would be to kind of, if I were to put it on a rigorous task, first would be get net CDF files into Python, read net CDF files with Python, try and put all those data values and their associate, just try to put all those data values into a single array, parse that array and create a histogram with all those values. And then create a variable, let's say threshold, that the user can customize to see anything above this will be cloud, anything below this will be water. And then using that threshold, create a percentage or a ratio of clouds to total pixels. So yeah, that's everything. Just about an hour. So if we have no more questions or anything, that's about it. Again, feel free to message me about anything. And that I'll see you guys. Bye-bye.
Enjoy your weekend.
You too.